So hello everyone, welcome to Statistics 11, more on measures of central tendency. The first thing we're going to talk about is what are called outliers. An outlier is a data entry that is far removed from the others. Let me give you the simplest example I know. Suppose we're all in this classroom and you exclude me, but all you students are in this classroom. Now you all have a certain amount of your money in your pocket, okay, or a certain amount of money you make, so you have an income. And if we were to find the average of the income, you all would be fairly close to that average, even if somebody has a pretty decent job. But suppose Bill Gates walks into the room. Now, Bill Gates' income is about, $5 billion a year. So he would do something, he would just, if you found the average with Bill Gates in the room, it would make it way too high, and it wouldn't be very representative at all. So Bill Gates would be considered an outlier. Now, you always have to make a decision whether you keep or throw out outliers. But in general, outliers are very important pieces of data that we need to pay attention to. All right, the second topic is on the topic of a weighted mean. Now, what's a weighted mean? Well, a weighted mean is where certain data in a list show up more than one time. So, for instance, I could get a list of, say, percentages in a class, or, body fat percentages, or a list of heights or weights, or something like that in a class. And when I get that list, I might come up with a list of numbers that would look something like this. Here's a list. Suppose I have data that's like 61, 64, 67, and 70, and suppose this data has a frequency of 4, 5, 8, and 1. Now suppose I want to find the average of this data. Well, I can't just take 61 plus 64 plus 67 plus 70 and add those up and divide by 4 to find the average. That would be absolutely wrong. And why is it? Because I actually have 4 61s and 5 64s and 8 67s. So in order to find the average, I really should do 61 plus 61 plus 61 plus 61 plus 64 plus ... 64 5 times plus 8 67s and plus 170, and then I need to divide by whatever the total here is, which is 18. So I would divide this by 18. So you can see there are a number of ways this original problem I wrote is incorrect. Number one is it doesn't have the correct total, and number two, it doesn't have the correct number of each individual value. So this is called a weighted mean when you do that. And on the next page, I'll show you how to do this weighted mean in the shortest form necessary. Let's go ahead to the next page, and I'm just going to list that table of data again. All right, and let's call it height, and let's call this our frequency, and suppose we had 61, 64, 67, and 70, and then we had 4 people who are that tall, 5 that tall, 8 that tall, and 1 person that tall. So to find the weighted mean x bar, what I would need to do is add up all these numbers. Now instead of writing 61 plus 61 plus 61 plus dot 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 like that, I can make this a little shorter, and I can say, well, 61, I'm going to add it 4 times, so that's 61 times 4, plus 64, I'm going to add it 5 times, plus 67, I'm going to add it 8 times, plus 70, which I'm going to add 1 time. And then I divide by essentially the 4 plus 5 plus 8 plus 1. And when we calculate that out, this is 244 plus 320 plus 536 plus 70, all divided by 18. And if you add those numbers up and divide by 18, then you'll get a solution. And that solution is 1170 divided by 18, which is equal to 65. So the average height out of this group would be 65 inches. Now, weighted means can also use relative frequencies in this position. So if I had the relative frequency, for instance, 4 out of 18 is about 20%, 5 out of 18 is about 28%, 8 out of 18 about 45%, and 1 out of 18 is about 6%. And so if I added those up, that's approximately 100%. I just guessed on those right now. And so instead of multiplying by 4 here, like I did, I could multiply by the relative frequency, and if I did that, then I should get the exact same answer, 65 inches. Now, I just sort of rounded these percentages and didn't make them exact, so we'll be close but not exactly on. But in general, if these are exact percentages or relative frequencies, then your answer is going to be exactly the same. So here's an example of a very typical problem that you'll have to do. Number one, you're given all this data over here, which is data that has to do with the number of days somebody has to spend in the hospital. And then what they asked me to do is make a frequency table right here. So the next thing I'm going to do is make a frequency histogram. So why don't you do that? See if you can copy the data, make the frequency table, and then make the frequency histogram, and then see if we match. And so if you made it correct, it should look something like this. A couple of things I want to point out. The first thing is, you'll notice that each one of these is only separated by 1 in the histogram. Therefore, the class boundaries are halfway in between. So it goes from 3.5 to 4.5, that's where the number 4s are. 4.5 to 5.5, that's where the number 5s are. So a proper one would be drawn in this way, not where you put 4 to 5 and 5 to 6. So you need to kind of watch out for those kinds of things when you're given just individual numbers. Think about the class boundaries as well, even if you have the width only being 1. All right, so now we've drawn a frequency histogram, and then what we'd like to do is we'd like to describe the shape of this histogram. And I'm going to write this down, and I'll tell you in just a moment later why this one is skewed right. I'll just write it down for now, and then I'll tell you about it in a minute. And then what I'd like for us to do is we would like to be able to find the weighted mean. And once we find the weighted mean, then that would be all we need. So that's going to be x bar equals. So in order to help you do that, I've taken a couple of pictures and I'm going to try and paste those in here to show you. So I have now pasted some Texas Instruments slides into this, and we want to find the weighted mean for all this data up here. We've now talked about what the shape, made the histogram, frequency histogram. Now let's find the weighted mean. So how am I going to do that? Well, first of all, as you can see right here in this number 1, this is number 1, I entered the data in the calculator, and you'll see right here, this is the last of the data right there, 9-1, 10-1. And in list 1, I actually entered the days in the hospital, and in list 2, I entered the frequencies. So in picture 2, what you'll notice is I did the one variable statistics, but I entered list 1, comma, list 2. And what that tells the calculator is the data is in list 1, and in list 2 are the frequencies. And therefore, it will redo the calculation as a weighted mean. So our weighted mean is equal to 7.6, and as you can see, the number of data we have is 20, which matches how much these add up to over here on our frequency table. So that's how I would do this on a calculator. All right, finally, last slide. So in this last slide, I want to mention briefly that, excuse me, I'm sorry about that. What I want to mention is that if you have a histogram, so if you have a histogram that does this, that tends to get lower and lower like that, then this is what we called skewed right. And if you have a histogram that does that in reverse, so for instance, if it looks like this, low, and then it gets higher, right, like this, then this is what we called skewed left. We call a domestic distribution, we call it symmetric if the distribution looks like this. If it's kind of small on both ends, and then it has a high point in the middle, we call that symmetric. And the last one is a uniform distribution. And a uniform distribution basically looks like a rectangle, or almost like a rectangle. This could be slightly higher, and this one's slightly lower. But in general, it looks like a rectangle all the way across. That's a uniform distribution. Now that you know how to use a calculator and everything, you should be able to do this assignment where you find the weighted means and you find the what kind of shape a distribution is. Okay, that's it.